What's up? Good morning, guys. How's everybody doing? I hope you guys are all doing great. We're gonna completely change things a little bit today. Instead of doing like overhead on the board lecture, I'm gonna go ahead and just work through it uh, at your own pace. That way, you guys can take your time and complete this uh, throughout class and throughout the day. And then tomorrow, we're gonna go into platelets and kind of wrap up our whole unit on blood. So with looking at white blood cells, we're going to take a look at this case from based in at the in during COVID's prime around this little girl named Isla May. Isla May. So she was rushed to the hospital. She had very swollen tonsils, and doctors knew that they needed to get her diagnosed and treated right away. So they had a couple different things that they needed to look at. So what do you guys think? Could be some other possible causes from her case. So again, she has swollen tonsils. She has bruising all over her body. She has red spots. What do you think? So doctors did several tests on her, and they drew some blood, sent it off to a pediatric oncologist, and did a CBC count. So all it is again is that we're looking at is they count her blood cells, and they what they found was based around this image over here on the right. So a lot of things that we can note here. So again, we have all the red blood cells. Again, a couple of things to note though is that again they're slightly less pigmented than normal red blood cells. Then we also have all these bigger cells in here. What do we think these guys are? So if you notice, they're actually white blood cells. Now, the type of white blood cell we will go into more depth here in a little bit, but you can kind of tell that there's white blood cells interacting with neighboring red blood cells in order to counter back and fight against disease and foreign invasion or whatever it may be that's surrounding them. Now, do we think again if we're looking at hematocrit levels, would she have a normal range for her hematocrit levels? No, she would not. So again, we have to take into consideration her total count of all blood cells, whether they're red blood cells, white blood cells, and even platelets, and then from there, again, it's the other remaining portions looking at the amount of plasma she has floating around her in a given test. So after that, they then took a bone marrow biopsy from her, and then which had allowed them to confirm her diagnosis. Which again, she has leukemia. So again, leukemia, I'm sure we've all heard of this before, but again, it's just a type of blood cancer that fights back against your immune system. And in her case, she had acute lymphoblastic leukemia. So again, if we're going to break this down, acute refers to how any sort of cancer disease progresses very quickly, and then lymphocytic refers to its overall effect on cells and how it can really turn against healthy white blood cells. So anybody with ALL and it often makes up about 75% of most children. Um, well, children make up about 75% of most cases, and they had to start chemotherapy on her right away. And again, we'll talk about chemotherapy later on. But again, we just know that chemotherapy refers to how we inject um, powerful drugs into our bloodstream, and it affects our whole body and how it all correlates with each other. Now, how does leukemia work? So again, it involves a, a, a lot of different things, and really takes effect on a lot of different portions of your body. So so starting off with again, we have our systemic system, which just comes back to how our body maintains homeostasis. So we begin to see weight loss, fever, and frequent infections throughout our body. Um, then within our lungs, our respiratory system, we have an easy shortness of breath. Our muscles become weaker. Our bones and joints become more brittle and a lot more tender. And our skin, this is a really big one. Really, all these on the right are very prevalent and often are very good clinical diagnoses and how we can go about um, diagnosing a immune system response of some sort. But to understand why homeostasis is disrupted, again, we got to take a closer look at how blood cells work. So again, you guys have already somewhat answered this question, but now how does blood maintain homeostasis? Now we can also tie in how does white blood cells help maintain homeostasis by the end of this video. So starting off with white blood cells, looking at leukocytes. So there's two main groupings of leukocytes, and then make sure on your guided notes that you're filling all this in as you go, specifically in that table. I would like that done by today. That way you have a pretty good understanding of what we're going into tomorrow with platelets in our kind of roundup assignment. So we have granulites, which granulites have all these fine little granules that kind of surround them. So there's three different types of granulites. We have a neutrophil, a xenophils, and basophils, and again, all these little granulites, and kind of dependent on how many different lobes within the nucleus each of them has, kind of acts as a distinguishing factor between all of them. And then we also have agranulites, which again, all that means is just we're lacking more granular cytoplasm. So then we'll take a look at monocytes and lymphocytes. All right, so the white blood cells are found again all throughout our bloodstream, and again, it's important to know there's usually not as many white blood cells, and generally there doesn't need to be, and they tend to be larger than red blood cells. Now, looking at leukocytes. So again, this chart over off the right lists the percentage of each type of leukocytes that are found within our bloodstream. But we can note some big irregular. So oftentimes we can notice clinical diagnosis and how each percentage of each type can really be altered and be a leading cause as to some different types of diseases. Now, there's three main types of lymphocytes that we can take a look at. We're not going to go to a whole lot of depth with them, but I think it might be helpful for you guys to know just as to what you're looking at. So T cells are a branch of lymphocytes that deal with just overall fighting against any sort of foreign invasion, whether that's cancer cells, any sort of parasitic infection, etc. We have B cells. These guys are super important in helping making antibodies. That way we can react to an immune response. And then finally, we have NK cells, or in other words, natural killer cells, which, just like how they sound, they are made specifically to fight back and kill cancer cells. Now, the next few slides, we're going to go into a lot of the different functions of each of these, whether they're agranular or granular, and then we'll go from there. So first one I have is neutrophil. So neutrophils, again, are oftentimes the most abundant in nature whenever we're looking at a CBC count. And their distinguishing factors is that they have a really deep purple nucleus and oftentimes contain 7 different lobes. So if I'm looking at this, I have a lobe here, here, and here. So there's 3 there. I see about 4 there. And then there's a handful of them in each one of these too. So again, you're looking for a deep purple nucleus and consisting of 7 more motor lobes. And what really connects all these together, so if you're looking right here at this one in particular, you can kind of see this in this one pretty well, is that they're connected by little strands of nucleoplasm that just hold it all together. Now, they act as, again, phagocytes, which again, they're really, really prevalent in skin infections of any kind, and you can see them big time, really present in pus. I know that's not really a pretty picture, but it gives you a pretty good understanding of how these guys interact with a general immune response. Now, another common example of when this really came to fruition was whenever we had these anthrax outbreaks earlier in the year. So back in the uh, early 2000s, we had this big anthrax outbreak, which it was essentially just a big um, bacterial outbreak that it doesn't really affect humans like per se how colds and flus do, but it is something that you could get, and you really only are only going to get anthrax due to this whole bacilli, um, no, bacilli bacteria through like the consumption of infected animals or contact of them, or even through just products that were already infected with it. Um, Neutrophils again were super important to help combating it back against that. But this just gives you another example of what we're referring to. So next we have a xenophils. So xenophils, again, these guys are they look somewhat similar compared to the other one. So again, we're looking for that granular cytoplasm all throughout the white blood cell. Again, and these guys have a more of a blue red type appearance of their nucleus. But where we really see these guys prevalent is what they do is, again, they attack parasites and are only about 2% prevalent in white blood cells, so they have a lower concentration. But they gather around like foreign invasion of any kind to release these enzymes from their cytoplasmic granules, so all throughout the cell, and uh, and again, those enzymes are released onto the parasitic surface, digesting it all completely away. Next, we have our basophils. So these guys make up a very small concentration of your blood, only about 1%. So we see these guys um, uh, really prevalent whenever I have some sort of inflammatory response occurring, um, and what they help produce is this is heparin, which just acts as a blood thinner. So in order to combat back against us, we often take in histamines, which again are act as just um, important important inflammatory reactions. And what these really and what histamines normally really do is that they make blood vessels very leaky, and then they try to attack other white blood cells to but well they try to attract other white blood cells to the inflamed site. So where antihistamines come in play is that, again, they help suppress this whole reaction as it occurs. Next, we have a couple different conditions that are correlated between those different types of granular um, white blood cells. Our first one we're looking at is dermatographia, which is essentially comes from there's no real known cause, but but whenever an individual is lightly scratching or rubbing their skin, it's going to create these welts, or these lines all throughout their body. And again, in normal cases, it only lasts for about 30 minutes or so to an hour, but it can also last for a couple days. It rarely happens any longer than that. But again, there's no real treatment necessary. Just you can do you can go through any sort of over-the-counter remedies like taking antihistamines, avoiding any sort of cold exposure. Will uh, will avoid directly rubbing your skin, etc. And then our next one we have is this cold urticaria. So again, all this means is that we have cold hives. So again, whenever we come into contact with a colder temperature or colder stimuli, again, we're going to develop all these welts all over our skin. There's no real cure for that. Again, all you can really do is just avoid the cold and um, take antihistamines. So our next one that we're looking at are monocytes. So we're starting to kind of get into the tail end of these white blood cells. So what these guys do, these guys again act as macrophages, which again, if we refer back to our cell structure stuff, macrophages, all they do is that they again ingest. Well, that again, they're large macro, and then the phage refers to how they act as big eaters of any sort of foreign invasion. So whenever we're looking at how they can also become dendritic cells, so again, whenever we're looking at how they can become dendritic cells, all that was really referring to is how they act, how they act, act and present themselves to the antigens on the surface to of a given foreign body, and essentially help boost our immune response to it. But again, look for that U-like shape with these guys. All right, next we have is our lymphocytes, and again, we primarily see these mostly in lymphatic tissues like our lymph nodes and our tonsils, etc. But these guys have a really dark nucleus and almost takes up the entirety of the cell, but very important in our immune system as they produce antibodies. So, common viral infection that we hinted on already. Again, the mononucleosis, or in other words, mono, or also called the Kissing's disease, which in this case, again, it is a viral infection. It can spread. It spreads from direct contact with any sort of fluid. In most cases, it's saliva, but it can also pass through semen and blood. Very similar to HIV and AIDS, which we're going to hit on here in a second. But there's no real vaccine that we know of that will help treat it. All you can really do is just take time, rest, and then take some time to rest and recover. And then again, looking at HIV and AIDS. So again, both of which really weaken your immune system big time. HIV weakens the immune system by infecting specific immune cells. In this case, they weaken CD4 T cells, which again we've already talked about how T cells help to combat back against foreign bodies in their role, but they are really good, really important at stimulating other immune cells as well, like our macrophages and our phagocytes and all our other types of white blood cells. But if we break down that word of CD4, all that's referring to is just having a cluster of differentiated a cluster of differentiated four, and add another layer into that. Again, it's just saying we have a glycoprotein. So again, if I have a glycoprotein, I have a combination of different proteins acting together and working together to combat a specific function. So HIV and AIDS was really prevalent in our man Queen over here on the right. So that's why he's a really good example of that. I'm sure a handful of you have heard about how Magic Johnson has had it. So if you look at either one of those guys, Magic Johnson was able to combat back against it by following treatment methods and antiviral drugs, whereas unfortunately with Queen he was not able to. Now again with AIDS, when we're looking at AIDS, again it's an acquired immune deficiency that combats back against those CD4 cells, and when those are really low, that's when we have opportunistic infections occurring. So if I have an opportunistic infection occurring, then that's saying that, hey, and my normal cold or my normal runny nose or my normal flu is going to be 10 times worse than it, or however worse than it would be for you if you have AIDS than you would in a healthy individual. All right, so let's take some time to kind of reflect back a little bit. So again, over on the left-hand side, we have lymphocyte. We have a lymphocyte. So again, distinguishing factor. The nucleus is dark purple and it almost encloses the whole cell. And then over on my right-hand side, again, I have a neutrophil, which again acts as a phagocyte. And again, we're looking for those 3 to 7 lobes as a part of that nucleus. Now, looking at this whole bone anatomy. So again, there's a handful of these different cells, specifically those T cells that are made directly from stem cells. Now, kind of reflecting back again a little bit, can you guys identify what these different cavities are called again? So again, I have this long cavity that goes across my diaphysis of my bone, and then I have this one that extends longitudinally away towards the surface of my bone. So again, I have the Havrissian canal acts as this vessel here, and then I have my Volksman canal that acts as this vessel here. And then in normal cases, like right here, we have that nutrient form and helps supply minerals and blood throughout the rest of the bone. So here are all the different types of cells that we talked about. Um, um, so in order of most abundance, you get a really easy way we can go about remembering this is never let monkeys eat bananas. So again, I think it's important that you guys understand the level overall abundance of each of these. So if you were to break each of these down, never refers to neutrophil. The L in let refers to the lymphocytes. The M in monkeys refers to monocytes, and then E eosinophils, and then B basophil. So again, neutrophil, lymphocytes, monocytes, xenophil, basophil. Okay, so to summarize the changes that take place in white blood cells, again, they're not functioning properly. So their immediate treatment that we're going to go out to is go through this remission, induction, consolidation, maintenance, all of which kind of correlate back to chemotherapy. So again, an individual that goes through chemotherapy, again, we're using powerful drugs to target these cancer cells, and as it spreads throughout the bloodstream, and it essentially takes a toll on your whole body, which is why we lose our hair, why we have digestive issues, why we see a decline in red blood cells, and an overall depressed or suppressed immune system. So looking at even her case or anybody else that you can think of, or even if you had COVID and you know how this feels, what kind of challenges do you guys think did the pandemic have for cancer patients? Take a second to see if you can identify that. So again, if you came to this whole idea again, how the pandemic took a really big toll on cancer patients, and how we and again, and how it already suppresses their overall immune response, especially if I'm going through chemotherapy. Again, it's just like what we talked about. COVID's gonna be one of those opportunistic infections. It's gonna be a lot worse with people going through chemotherapy and have cancer, etc. So other types we can look at are radiation therapy, stem cell treatments, bone marrow transplants, and immunotherapy. But looking at this whole survival rate of children with ALL, again, it's about 90%, which it's honestly really good. Obviously, we would love to get it up to 100%. And and doctors and scientists are constantly working to figure this out to better those odds as we go on. Now, again, thank you guys again. Make sure you guys are taking time to look through your book and look through the books that are in the back of the class, and that might help bring all this together even more, especially if you're still struggling. Identify some of these different structures. But for today, I would work on again finishing up those hematocrit and the hematocrit, the feedback loop paper, and now you can go ahead and even start everything else within that. But then tomorrow we're going to have one kind of summative assignment over everything. But if you have any questions, please let me know.